In this picture, we can see the team is preparing to launch their latest aircraft in our inventory, the Axon M14 Viper. This aircraft configuration has the Casia 360 system on board. It has 5 cameras. Each camera has a field of view of approximately 80 degrees. And so that allows us to install these cameras with proper overlap of each other and still ensure a full 360-degree field of view around this aircraft. And this is really important to ensure that regardless of the incident angle of the potential encounter of an aircraft, it will be seen by our Casia system. This aircraft is a wonderful aircraft because it can fly upwards of about 10 hours and is equipped with a gasoline engine. We're now about to observe one of our pilots, Greg, launch the M14. He is in communications with the mission commander and the ground control station operator. And upon completion of all pre-flight checks, we then accelerate the aircraft. And once we reach a flying speed of approximately 45 miles an hour, the pilot will then rotate and launch the aircraft in the same manner as he were a pilot on board the aircraft. In fact, Greg there is a multi-engine commercially rated pilot. Once the aircraft is safely aloft, we'll put it in autonomous flight mode and we'll fly it to our intended test site. In this case, again, over a desert area here in northern Nevada. In this view, you can see that the ground control station operator has already pre-programmed a flight route that we intend to fly the aircraft, and the aircraft is doing that autonomously. All the while, Casia is independently looking at the horizon 360 degrees with the 5 cameras and assessing whether or not there are any other aircraft in the area. The dynamic tracker looks at each one of those videos separately to assess if there's another aircraft. We use that mound, the dark object you see to the left center of the field of view, as a reference point for our general aviation aircraft. As when they fly these near-intercept geometries, we'll use both vertical and lateral separation to safely ensure the aircraft pass safely when proximate to each other, but yet ensure that the Casia system believes the risk of collision exists to cause a collision avoidance maneuver. In this view, we see an oncoming aircraft from the right in orange. There's the M14 going in the opposite direction toward the oncoming aircraft. And the Casia system is now assessing. Note that none of these images are being projected to the ground control station operator. All this processing is occurring on board the aircraft. And look, it sees an oncoming aircraft. And when it does that, it causes the onboard autopilot to do an avoidance maneuver. In this case, to make a right-hand turn and eventually do a descending spiral. Here's a live camera we put on just to give you a better sense. And you see the oncoming aircraft and the drone do an avoidance maneuver prior to the closest point of approach to safely allow the general aviation aircraft to continue on its mission, and while the drone in a manner consistent with Part 107 yields right away. And in this case, we're doing a right-hand descending spiral. And Ryan has flown this X-Cub for a number of months with us, but he is in a variety of aircraft done something in the order of in excess of 14,000 intercepts against drones equipped with Casia system. That's what gives us the great amount of confidence of how well our system works. So this morning we just completed a series of intercepts where we fly our general aviation aircraft in a very carefully controlled set of intercept geometries against our drone that is carrying the Casia detect and avoid technology. During each of these intercepts, we observe the drone do an appropriate evasion maneuver, and we then reset the drone to set up to do another run. So this morning we did approximately 50 runs, which is a great day for us, and is how we've been able to generate over 14,000 intercepts over the last 2 years.